Hello, welcome to our new content. This time, let's do electrical design analysis for single family dwelling unit. So, kakaiba tong topic natin ngayon. And this topic is, ang reference natin is yung Philippine Electrical Code 2017. And then, for those who are asking about the soft copy, please email me para ma-direct ko yung files sa inyo because I cannot attach on this sa YouTube. Di pwede maka-attach. So please email me para mabilis ko ma-identify. And then thank you din pala sa mga suporta ninyo sa walang sawang panonood. Actually, we are now reaching 1,500 plus subscribers. So salamat sa inyong lahat, and then please do support sa mga content na natin para meron pa tayong mga kasunod na gagawin. Okay, so ito is for single family dwelling unit. So ano ba talaga yung single family dwelling unit? And then when we say dwelling unit, so a structure used as residence. It has one or more rooms for sleeping, cooking, and toilet facilities with a private entrance from outside the building or from a common hallway or stairway inside the building. Actually, pag dwelling unit, that is only composed of one room. Pag more rooms na, ang tawag dyan is multi-dwelling unit. Okay, so yun yung definitions. And then let's do the design analysis. Okay, our situation is this. The dwelling unit has a floor area of 145 square meter. So it has typical household appliances, including one unit of 1.5 HP air conditioning unit. So we need to determine the service entrance conductor and then the service equipment. Okay, so to start with this, let's do the lighting and receptacle load calculations. Okay, so we have here the actually ito yung calculations na gagawin natin. First is the general and lighting and receptacle load, small appliance load, saka laundry load, and then this one, the air conditioning unit. So first is we need to do the general lighting and receptacle load. So based from the PEC, that is from the table 2.20 .2.3, the general lighting loads by occupancy. So type of occupancy, unit load, volt amperes per meter square. So yung ating given is actually residential siya, belongs siya sa dwelling unit. And then if this is yung application, so the unit load is 24 BE per square meter. So if we need to calculate this one, we have given the floor area, which is 145 square meter. So for the calculations, this BE per square meter, 24 BE per square meter, so multiply mo ng 145, so cancel out the square meter. So the total load for lightings and receptacle is 3,400 ETBE. So we will use this value doon sa ating calculations. Okay, so we're done for this general lighting and receptacle load. So next is this small appliance load. So let's look again doon sa PEC. So from the table, 2.20.3.13 for the small appliance and laundry loads for a dwelling unit. So for the small appliance circuit loads, in each dwelling unit, the load shall be calculated at 1,500 volt amperes for each 2-wire small appliances branch circuit. So pag small appliance circuit load daw, so yung ating load shall be calculated at 1,500 BE. Actually, the value is given, so for our calculations for small appliance load, that is 1,500 BE. So let's use this value dun sa ating calculation. Okay, so we have here small appliance load 1,500 BE. Again, for the laundry load, so let's look again on the PEC from 2.20.3.13 for small appliance and laundry loads for dwelling unit under letter B. So for laundry circuit load, a load of not less than 1,500 BE volt amperes shall be calculated for its 2-wire laundry branch circuit. So malinaw dyan that yung laundry load daw is 1,500 BE. So for calculations for laundry loads, we have 1,500 BE. So galing din siya sa PEC. So let's use this value again. Okay, so from the PEC, we for our laundry loads, we have 1,500 BE. So after that, get the subtotal. So 3,480 plus 2,150. So we come up to 6,480 BE. So after this one, let's use PEC for the applications of demand factor. From the PEC, 2.20.3.3, so lighting load demand factors. And then type of occupancy, we have this one, dwelling units. Portions of lighting load on which demand factors applies, volt amperes. Then we have this demand factor. Then for the dwelling unit, so first 3,000 at 100%. First 1,000 no 3,000. Okay, so first 3,000 we have times 100% demand factor, so obviously that is 3,000 BE. So and then from 3,001 and then to 120,000 at 35 demand factor. So yung 6,480, let's deduct the 3,000. So that is yun na yung remainder niya at 35 demand factor. So 6,480 minus 3,000, multiply mo siya ng 0.35, so we have 1,218 BE. So let's use this value for the for our calculations. Okay, so 3,000 and then remainder niya is 1,218 BE. Okay, to continue, so from the subtotal, we're using for demand factor. So we have this one, 3,000, and then remainder at 1,218 BE. So we're done on the typical household appliances together with the lighting and receptacle load. So next is we have this one, itong aircon unit. That is 1.5 air conditioning unit. So this is additional loads or known as other loads. Okay, so we have here other loads, that is 1 unit of 1.5 its PECU. So let's use the PEC to solve for the load calculation. from the table, 4.30.14.2 for motor full load currents in amperes for single phase AC motors. So ang ating given is 1.5 HP. Ito yon. And then 230 volt system. So to get for the full load current in amperes, we have 10 amperes. Okay, so let's use this value. And then to get for the aircon loads, in terms of BE, we have 230 volts. Multiply mo siya ng 10 amperes. So we can come up with 2,300 BE. Let's use this value dun sa ating calculations. So from the PEC, we have 2,300 BE for our aircon load. And then next is get the total of these three. Okay, 3,000 plus the remainder 1,218, and then 2,300 BE. So we get the total of 6,518 BE. So this is our total net computed load. And then to calculate for the load amperes, so that is 6,518. So divide mo lang siya ng 230 volts by using Ohm's law. So our load amperes will be 28.33 amperes. So from this, we can do the calculations for our branch. For the service entrance conductor. And then let's use the PEC for our service entrance conductor sizing. So from here, from PEC 4.30.2.4 for several motors or motors and other loads, so combination siya. Okay, conductor supplying several motors and other loads shall have an ampacity not less than the sum S of the following, and then 125% of the full load current rating of the highest rated motor, so as determined by 4.30.1.6 quantity A. So let's use this condition. From that condition, we can simply calculate for the service entrance conductors by applying PEC 4.30.2.4. Again, so our load amperes, we have 28.33, this is 1, plus 125% of the full load current ratings, which is 10 amperes. So to calculate that, yung result natin is 40.83 amperes. And then by applying the speedometer ampacity, so yung ating load amperes, applying PEC, we have 40.83 amperes. So let's multiply this by 1.25 for this spare capacity. So dapat dun sa ating load, so dapat 80% lang yung ma-consume ng yung ating service entrance conductor. So we have 40.83 times 1.25, we have 51.03 ampere. So from this, we can size na yung sa ating service entrance conductor. So let's look on the PEC again. So okay, from the table 3.10.2.6 quantity B 16. So we have mm square, TW, and then THN, THWN, THW, or TSW. And then from our calculations, for our feeder ampacity is 51.03 amperes. So if we look on the table, if we use the 14 square mm, so at 60 degrees Celsius TW, we have 55 amperes. Pag THN HWN or at 75 degrees Celsius, kaya niya is 65 degrees Celsius. If we use, actually, kung 8.0 lang, so we have 50, almost 50. So, this one is 51.03. Much better to use this 14 square mm TW. At 60 degrees Celsius, meron siyang 55 amperes. At 75 degrees Celsius, meron siyang 65 amperes. Okay, so let's use this size of wire. Okay, so for now, we have already size for service entrance conductors by using PEC. So we can on the table, so we need to use this two 14 square mm TW wires. Okay, and then to continue, so let's do the calculations for the determine for the service equipment. Again, let's use PEC for this as reference. So from the table, 4.30, 4.2 for the maximum rating or setting of motor brand circuit short circuit and ground fault protective devices. So we have type of motors, and then percentage of followed current. So non-time delay fuse, dual element time delay fuse, instantaneous trip circuit breaker, and then we have inverse time circuit breaker. So for our design, let's use this inverse time circuit breaker. Okay, so we have, for the single piece motors, our multiplier is 250%. Okay, so design efficiency, so maganda to 50%. Let's use the inverse time circuit breaker. Okay, to continue for the calculations, we have maximum current rating of protective device. We have inverse time circuit breaker. So again, 3000 BE plus 1218 BE plus 250% of these motor loads, 2300 over 230 volts. So we can have the 43 amperes. So let's use this reference to size up yung ating service equipment, or your other term is the circuit breaker. If you look on the PEC, 2.40.1.6 standard ampere ratings, fuses, and fixed strip circuit breakers. Okay, ito yung standard ampere ratings for fuses and inverse time circuit breakers. So yung ating calculation is 43 amperes. So the circuit breaker closest is 45 amperes, 50, 60, 70, or 80. So for me as a designer, so if I use this 60 ampere circuit breaker, so meron ka pang if kunin mo yung 80% niya, so merong almost 46, 60 times 0.80, actually 48 amperes. So meron ka pang spare capacity kaysa sa 50 amperes medyo closest. So what if meron kang expansion of the sa future loads mo. So I use this 60 ampere trip circuit breaker. Okay, so from the PEC as our reference, we have this 43 amperes. If we use the circuit inverse time circuit breaker, so it's better to use 60 amperes ampere trip circuit breaker, 2 pole 60 Hz, and then molded case circuit breaker, also known as MCCB. Okay, so actually we're done already with the requirements. First is the service entrance conductors. We have 14 square mm, and then service equipment we have 60 ampere trip circuit breaker. Okay, to sum up, actually para madali yung ma-visualize yung ating output. So for this single family dwelling unit na meron siyang floor area na 145 square meter, typical household appliances including 1.5 HP unit, aircon unit. Okay, so we have here service entrance conductors and then service equipment. So to visualize further, so let's construct up actually panel board diagram. Paano yung installation actual? Paano yung manufacturing ng panel board? Okay, so we have here the panel board diagram for this design analysis. So I construct this para ma-visualize nyo yung calculations, otherwise yung output. Again, yung ating recommendations, we have service entrance conductors, we have two 14 square mm MTW wires. Ito yon, is coming from electric utility or meter center. Okay, ito yung line. So and then if we look on the PEC, so that is 8.0 yung ground wire niya, TW din. Okay, so yung main is 60 ampere trip circuit breaker. Ito yun. And then actually for the design sa panel board, so yung much better yung lighting is let's separate that dun sa outlet. Okay, we have this one, the panel board branch 1. This is for lighting. Panel board branch 2, that is for outlet. Okay, so for small appliance load, ito na yung 1500 BE. Circuit number 3. So for laundry loads, that is 20 ampere trip to pole circuit breaker. So for the 1.5 HP ECU, so yung kanyang pole current is 10 amperes. So fit pa rin siya sa 20 ampere trip na circuit breaker. Or pwede kang maggamit ng 30 ampere trip. So depende sa supplier. Okay, circuit number 5. And then for circuit number 6, we have the spare. So for ano yan, future loads, ano pang idagdag mo sa future. Okay, so ito yung construct ng yung ating design analysis, and then paano yung maggawa ng actually paano mag-design ng panel board diagram. So if you have this one, punta ka sa supplier. So tatanungin ka ano yung main, ano yung branches. Actually pakita mo lang to, or meron kang load schedule, much better. So pwede rin yun. So if you have this one already, yung supplier, mas madali ka nilang i-accommodate because yung data is given naman and then malinaw. Okay, so I'm sure na nabigay ko lahat yung design analysis for the single family dwelling unit. Please subscribe para kayo updated sa mga incoming na videos na gagawin natin. And then please comment din. So welcome ko yung comment nyo. Ano yung magiging or suggestions for the succeeding, ano yung mga next topic na gagawin natin. So I appreciate that. Then I hope meron kayong natutunan sa ating konting discussions or content. So maganda to for yung mga practitioners, sa mga electricians, or even the students. So, meron kayong nakukuhang idea coming from the Philippine Electrical Code. So much better if kayo na designer sooner. So pwede nyong sundan to. Okay, so maraming salamat.